first things I did with my AI was make computer code more efficient. So back, oh my God, over 10 years ago when I came up with the computer programming itself, and then we ran through all the combinations of code. Um, what we did by running through all the combinations of code was run code through it and then find the most efficient way of writing that code. So basically, we'd break it down to assembly and machine code as well, and you'd write in a higher level language, and we'd write a lower level language that performs the task as simply as possible, as efficiently as possible. So what you could do now though is with AI, is that we have an AI OS, right? We have an AI that goes through each piece of the OS and builds its own piece of the OS. Now you could have just an AI try to build its own system itself. So right now we're copying systems. What if the AI were to build its own system that's good for machine learning, that's based off machine learning and machine learning nodes and stuff? So so when you train an AI or write an AI, what you should be doing is the same thing as my initial AI. Is you should be going over your AI and making it more efficient. You should be trying to find the simplest, easiest, most efficient way of performing this task, and having that at your foundation or the fundamental in your fundamental ways of performing tasks. And so this is like we have an AI going over each piece of the operating system, maybe as far as creating its own architecture and its own pieces of the operating system that still get general tasks done, that still get the bigger picture done. And what we want to do is understand our AI. We want to go through our AI and have our AI database all of its nodes. We want the AI to database everything it's machine learned. And now we want to go through it, and with the machine learning nodes and with the database of what the machine learned, create a more efficient AI, create a more effective AI, create a more simplified AI that runs on even less power and less operations. And what you could think of, one of the main things that I did was make a little AI for everything. So we have an AI for every component of the operating system. So now what I'm thinking is, now that we have this database of everything that the machine learned, we have all these machine learning nodes in this machine learning database, we should create an AI for each of the machine learning nodes, create an AI for each of the machine learning database pieces, and see if there's a simpler way that we can get this node or whatever variables in the database there. If there's a simpler way that we can perform this information or this knowledge than we have documented right now. And especially if this node has to go through a process, or if this variable has to go through a process for us to understand the information, there might be simpler processes for it to go through, or there might be other variables that can do the same thing with a simpler process. Smaller variables, other variables, or there might be a more complete variable. A more complete variable that can do more processes than just this process, and it's it's effectively using less variables by using complete variables, and that's easier to work with, perhaps. So basically, what you want the AI to do is everything. You want the AI to go through the AI, break down the AI, and then write a new program, write a new version of the program, write a new AI, exactly. Want the AI to go through the AI, break down the AI, and write the AI. We also have an where we want the AI to maintain and operate a system. Like, where, if you ever notice that servers have maintenance and stuff, we want the AIs to perform the maintenance and operate the servers and maintain them as well. So that's the other thing that you can look at, is that a computer built with machine learning with completely different architecture, perhaps, like what's best architecture for the machine learning variables, machine learning nodes, and now how do we maintain that? How do we maintain that, and how do we upkeep a machine learning design, machine learned design, and not only maintain it, but maintain it with machine learning, as well as we want to understand, as well as when the machine learns something and we are doing something functional with it, we're now doing something functional, we can understand how that machine learning works. If we want to break down the database of all the machine learning, everything the machine's learned, and now we're doing something functional, we can see what how the machine's thinking in a way. You can see how the machine's thinking in a way. You might want to create like a visual adaptation of this, of these nodes working visual, actual visual, to solve the puzzle, to solve the similar to circuits, because it's all underneath this is all simple circuits, really, or not necessarily simple, but integrated small circuits are performing all these actions, right? These are all clicks of the switch, and a circuit's performing operation, and basically you could view these operations that the machine nodes, the machine learning database is doing, and compare that to a CPU, compare that to the circuits in the CPU, and see how the circuits in the CPU would be working when the machine nodes are working this way and the CPU is working this way, and you can really break it down into understand how this AI is thinking. And then when you put the two together, you get a more comprehensive computer that now the software understands how the hardware works, and the software is coming up with hardware that will work better with its software too, right? So this is a great operation to come up with better hardware to work better with your software if you've chosen a specific software route, or once again conform your software to work with hardware if you've chosen a specific hardware route. So this is about the AI going through the AI, making the AI more efficient.